In this video, we are going to evaluate exponential functions. Exponential functions are a special type of function where the variable is an exponent. These functions can grow or decay rapidly. They're used to model all sorts of real-world situations in various fields such as finance, biology, and physics. Linear growth creates a line and increases at a constant rate. This sequence of numbers shows linear growth because it's increasing by 2 every time. An equation for linear growth might be written in slope-intercept form. In this equation, each time the x increases by 1, the y increases by 3. The exponential growth shows a curving pattern. And we notice it gets steeper and steeper and steeper and steeper, so it is not growing at a constant rate. This pattern is doubling each time, so we're multiplying by 2 each time. And we notice each time it's growing by more and more. We're adding 5, then adding 10, then adding 20, then adding 40. There's an equation showing exponential growth, and we notice that x is in the exponents. Here we have an exponential function, and we're going to evaluate it when the input is 5. So to find f of 5, we replace the x with 5 because the input is 5. And since 5 minus 4 equals 1, we just need to figure out negative 9 to the first power. So f of 5 equals negative 9. Once again, we'll find f of 5. So we'll go ahead and plug in 5 for x on the right-hand side of the equation. All right, 5 minus 3 is 2, so we have negative 10 to the second power. Negative 10 squared is 100. These numbers are both divisible by 2. So f of 5 equals negative 50 over 3. And we could divide that on a calculator to figure out the decimal as well. All right, this equation represents the number of elk present in a population in T years. And we're going to use the equation to estimate the number of elk in the population in 38 years. And we'll round to the nearest elk, or nearest integer. All right, so we want to find f of 38. Now in this equation, or in this function, we notice there's an e there. Now, in mathematics, e is actually a number. Now we will typically use the button on our calculator for e, but e is about equal to 2.7. Now, e is a special number like the number pi. It's an irrational number, so it never repeats and the decimals never stop. So the decimals keep on going after the 7 here. So we're going to use our calculator to help us figure out f of 38. All right, so I have 20 times e raised to the power of 0.05 times 38. Let's go to our calculator and we'll type in 20 times e. We don't see e on this screen. We do see pi, but not e. Now on the ABC screen, there's an e, but that is not the e we want. Let's go to, because that's just the like a variable e. Let's go to function, and there it is, right next to pi. We have the number e. So 0.05 times 38. So we have 20 times e raised to the power of 0.05 times 38. And that equals about 134. Remember, we wanted to round to the nearest elk, or nearest integer. So 134. Let's put a label on that. We were estimating the number of elk, so we have 134. Here we have a formula for compound interest. So that's if you are receiving interest in a bank account or an investment or something like that. So let's review what each of these pieces are. Now the A there, that's the final amount that you end up with. P, that's the principal. And that's what you start with. The R, that's your interest rate as a decimal. So not as a percentage. If it's given to you as a percentage, you have to change it to a decimal. Now T, that is time, and it's in years. By the way, the interest rate, when we're dealing with interest rates, we're always working with annual interest rates. So T will always be in years. But with compound interest, you might be receiving interest more than once a year. So N, that will be the number of times interest is applied per time period or per year. So a complicated looking formula, but let's give it a try piece by piece here. So Ed invests $1,000 into a savings account which earns 3% per year. In 10 years, how much will Ed's investment be worth if interest is compounded monthly? Round to the nearest dollar. So let's write down the formula we'll be using. We have A equals P times 1 plus the interest rate over N raised to the power of N times T. All right, we're looking for A. That's how much money he'll have in 10 years. The P, that's how much we start with. So he started with $1,000. And it's always 1 there. 1 plus the interest rate as a decimal. So that's 0.03. Now here it says we're compounded monthly. Now there are 12 months in 1 year. So N is going to be 12. If this was compounded quarterly, it would be 4. Compounded daily, 365. Raised to the power of N, so that was 12 times T, which is the number of years. In this case, 10. Okay, now these little pieces here actually kind of make sense. So the interest rate is an annual interest rate, but we're getting paid interest every month. So we have to divide the annual interest rate by 12. So this will be the monthly interest rate. And since we get 12 interest payments per year in this case, since it's compounded monthly, we'll have 12 times 10 interest payments after 10 years. So it's the number of interest payments we're getting. All right, let's go ahead and figure out 0.03 divided by 12. So I'm going to go to the calculator for that. 0.03 divided by 12. Okay, that equals 0.0025. So each month, the interest rate is 0.25%. But in this case, we'll be using the decimal version, 0.0025. So that'll be 1 plus 0.0025, or 1.0025, raised to the power of 120. All right, let's go ahead and enter this expression into the calculator. So we had 1,000 times 1.0025 raised to the power of 120. We're rounding to the nearest dollar, so 1,349. So in 10 years, Ed's investment will be worth $1,349. Now here we have another interest rate formula. This is for investments that compound continuously. So instead of daily, instead of monthly, it's compounded continuously. And here our E comes in handy. So we have P, what we start with, multiplied by the number e raised to the power of the interest rate as a decimal times time. So Tori invests $4,000 into a mutual fund, which earns 7% per year. In 20 years, how much will Tori's investment be worth if interest is compounded continuously? Round to the nearest dollar. All right, so here's our compounded continuously formula. Area equals the principal, multiplied by e raised to the power of the interest rate, multiplied by time. Right, she starts with $4,000. Multiply that by e. 7%, that's 0.07 as a decimal. So raised to the power of 0.07 multiplied by the number of years. So multiplied by 20. Okay, let's figure out 0.07 times 20. Start with that. That's 1.4. Let's go ahead and type this expression into our calculator. 4,000 times e to the power of 1.4. I want that round to the nearest dollar, so 16,221. So rounding that 0 up to a 1, since the number after it is 5 or bigger. So 16,221. All right, so we figured out how much her investment will be worth in 20 years. All right, I hope this lesson about evaluating exponential functions has been helpful. This is Mr. Ela signing off.